All right, so this lesson is going to be about the digestive system. Make sure you have your sheet of notes that you took home in your homework packet on Thursday. Fill those notes in as you go. Bring those notes with you to class on Wednesday because we're going to use those either Wednesday or Thursday whenever I can fit it in to do a couple of other sciencey things. So what does the digestive system do? It takes food that you eat, it converts it into materials your body needs to live, to repair itself, and to grow. Your digestive system includes all organs related to taking in food, breaking down food, making that food useful to the body, and then getting rid of whatever's left over that your body doesn't need. There are a couple of organs, like the liver and the gallbladder, that food does not pass through, but it is still part of that digestive system. And this is the picture in your book that I believe your textbook is page 69, and we're going to talk through a whole lot of these pieces. The part of your digestive system that food passes through is also called the gastrointestinal tract, or GI tract for short. It is also sometimes called the alimentary canal. So if you hear either one of those words throughout this lecture, in your textbook, in your homework, wherever, know that those are those are other words for the digestive system, the part of the digestive system that food passes through. All right, when you eat, you're eating all sorts of nutrients. For right now, we're going to focus on three things: carbohydrates, proteins, and fats. These are the three main nutrients your body needs, and your digestive system handles each of these things in different ways. The main thing your body is interested in doing with the food that you're eating is breaking down those carbohydrates, breaking down the proteins, breaking down the fats into smaller chemicals. Your body then uses those chemicals, and the reality is when we have the right balance of those three things, your body can do a myriad of things with them. Things like building, growing, repairing cells, repairing and building tissues, your organs. All of those things happen by the nutrients pulled out of the food that you eat. All the rest of that stuff that you eat goes through your body. Your book handles this very delicately. Tosses it out through a process called defecation. That's the last step in digestion, and that's where the body removes all of that waste product that you've eaten. Okay, I say okay a lot when I start a new slide. Sorry. Digestion begins the minute food enters our mouth. We sort of assume that digestion begins when we swallow and the food begins to move, but the reality is it begins the moment we put it in our mouth, with the chewing and the ripping of the food. All of that is part of digestion. And that's called the mechanical digestion. That's that process of grinding up the food and then moving the food along into the rest of the digestive system. There are several different types of teeth we need to look at, and I'll be honest, teeth absolutely gross me out for some reason, but that's all right. First of all, we have incisors, and those are those top four teeth, and I'm assuming the bottom four are part of those as well. Those are sharp, and they're useful for biting into things. Then we have our cupsids, and those are also called your canine teeth. They're sharp. They're made for like tearing food, not just biting it, but tearing it apart. And then you have premolars and molars, which are those big teeth in the back. That's what we use to grind up our food. If you only had those teeth for tearing, you'd have a really hard time chewing your food. You'd have to swallow big chunks of food, kind of like an alligator does. And if you only had molars, you would struggle to kind of rip food off or like bite into an apple. Our teeth are designed specifically for what our diet is. Animals that have different types of teeth based upon what types of food that they were created to eat. Your textbook goes over all of the parts of the tooth, and that picture I took kind of is messed up on the left side there, but you can tell what it says. So first of all, you have Teeth are covered in an extremely hard, white, shiny substance called enamel. Enamel is not a living substance, but it is the hardest substance in your body. Now, you can like brush your teeth so much that you brush the enamel away. I have a friend who had OCD in high school, and he brushed his teeth so much, that was like his thing, that he genuinely brushed his enamel away. Had to have some kind of surgery done. It was terrible. Anyway, so outside is the enamel, hardest substance in your body. Under the enamel is what's called the dentin. This layer is alive because it contains cells. Now, what this level does, or this layer does, is it's sort of like a shock absorber. It helps support that enamel, keep it where it needs to be, and it absorbs the shock that might otherwise damage your tooth. Below that is what's called the pulp, which this is where nerves and blood cells can be found. If you're eating ice cream or drinking something that's super hot and that hurts, that pulp is sort of what is where you're feeling it. That's the part that's sensitive. Then you have the thing called the crown. The crown is the part of your tooth that you can see above the gums. Below that, your teeth are like rooted into your jawbone by your roots. And I'll tell you really something disgusting. I had to have a tooth pulled once. My back molars, and when they do that, they have to go in and break up those roots because they grow into your jawbone, and break that part of your jawbone to get it to extract a tooth. So at the same time, chemical digestion is happening. Chemical digestion is beginning. Food is made up of all sorts of chemicals. Those chemicals, though, need to be broken down, changed into smaller components so that our bodies can use those chemicals. To get the process started, our mouth makes saliva or spit. Saliva is 99% water, but it does have special chemicals in it that do a couple of things. Number one, it protects your teeth. It keeps them covered and safe. Number two, it begins to break down food. And then number three, it protects your mouth against infections. So, we have a thing called a salivary gland, and we're going to look at a picture in just a second. The opening of that salivary gland, that takes saliva from our salivary glands into our mouth, okay? You smell something sour, those salivary glands kick into action. So here's how that works. There's a chemical in our saliva. One of the chemicals in our saliva is called an enzyme. Enzymes are just chemicals that help our bodies break down food. This specific enzyme that breaks down starches is called allimase. Starches are found in potatoes and bread and rice and beans and corn and a lot of other foods. And so we have to break down starches, we have to break down carbohydrates, and it starts with our saliva. This is the picture in your textbook, and basically the process, very elementary explanation. Our salivary glands, and you can see they're not pretty. They're all around your mouth. They are producing saliva. That saliva then goes through those little tubes, which are called salivary ducts, and it pushes that saliva into your mouth, which then is used to break down those carbohydrates. Our tongue is another part of this process. As you're chewing, your tongue is making special movements, and basically it forms a ball of food that we call a bolus. Now, the reality is your tongue is a voluntary muscle, but we don't really have to think about these movements. It's one of those trained, we just do sort of without thinking, even though our tongue is a voluntary muscle. Your textbook has a picture here that I've taken a picture of and put in here explaining how this works. So after you swallow the bolus, the food goes down your esophagus into your stomach, but it does not go into your lungs, which we know that. But here's the thing. When you breathe in, air passes through your nose or mouth down to your throat, and it goes into your lungs. So the question is, how does this happen? Because the larynx which leads to the lungs, is literally right in front of the entrance to the esophagus, which leads to your stomach. So even though the larynx and the esophagus are close together, there is a system in place that leads the air to our lungs and our food to our stomach. So here's a diagram, and see if this makes sense. The roof of your mouth is called your palate. The front is your hard palate. The back is your soft palate. When you swallow, the soft palate moves up in such a way that it seals off your nasal cavity, so you can't breathe and swallow at the same time. Now, if you've ever laughed while you're drinking a soda or whatever, and that comes out of your nose, one time I was laughing so hard I sprayed soda out of my nose, and most people have done that before. What happened is the laughter broke that seal and it allowed the liquid to go that direction. So when done correctly, that closes off that nasal cavity. So while you're swallowing your food, there's this special flap of cartilage called, and I'm probably not going to say this right, but the epiglottis. That's at the back of your throat. It drops down over the larynx, which is the part that leads to your lungs, and that way the bolus is guided safely over. It goes over that epiglottis and into the esophagus. So there's a lovely picture there of how you can swallow correctly and breathe correctly. Food is pushed into your stomach by the muscles of the esophagus, and there's two muscles that do this. There's one layer of muscle that's this long muscle that runs up and down the esophagus. There's another layer that is circular. It wraps around the esophagus, and those muscles contract and then relax, and as it's pushing and releasing, it's pushing the food through to the stomach. Now, where the esophagus and the stomach meet, there's a special circular muscle called a sphincter. That sphincter is a flap, basically, that opens and closes. Not a flap, it's just a muscle that opens and closes. It's contracting and relaxing, and that way the food can go in when it's supposed to go in. Now, there is a special muscle, and I'm going to say it very slowly so I say it right, called the gastroesophageal sphincter. This sphincter is most of the time it's closed. Okay, it's contracted so that food being digested doesn't go back up into the esophagus. It stays closed so that as it's working its way through the esophagus, it's secure. Then it goes into the stomach, and then it closes back up so that it doesn't go back up. Mine is broken, and so mine doesn't work right. When the muscles of that esophagus push the bolus along, the sphincter relaxes, food can pass into the stomach, and then it closes again so that it stays in the stomach. The stomach is a muscular pouch, and it's designed to store food for a short amount of time. And when it's empty, it's like this wrinkly balloon. And then when it fills up, that stretches out. But it's only meant to store it for a short time. The acid, you have acid in your stomach, and it has two jobs. Number one, it kills many a different kind of bacteria to keep you from getting sick. Then it breaks down the proteins you need into smaller chemicals so your body can absorb them and use them. And that sphincter that closes, when it closes tight, it keeps that stomach acid in your stomach. The problem is that stomach acid, excuse me, is very potent. It's very powerful. I've read, and your textbook says this, it is so strong it would burn your skin and your internal organs quite severely if it ever actually came in contact with things. So your body has this, it produces a mucus. Mucus is just this thick, slimy liquid. Snot is a mucus. And that mucus in your stomach lines the outside or the inside of the lining of your stomach. The mucus coats it. And that way the acid never comes in contact with the actual stomach lining, or it would just burn it up. For real, my sphincter there is broken. I had to go in and do I sent a camera down my throat, and mine's broken, and that bile, that acid in there will bubble back up into my esophagus, and it burns like nobody's business when it gets back in there. Mine also, if I ever have a fully empty stomach, if there's not enough food in there, the acid will begin to eat away at the lining of my stomach. Because that flap is broken, it doesn't keep the mucus in, and it's a big thing. So I can tell you that acid will set you on fire, and it really does hurt. It's very strong, and the Lord put this layer of mucus so that your acids could break down the proteins that you need, because your carbohydrates have already been broken down in your esophagus through your saliva. Now your stomach is breaking up your proteins from the acid that is there. The stomach has a powerful enzyme called pepsin. It uses pepsin to break down the proteins into smaller components so that your body can use those components to do all the things that it needs to do. Cells that line your stomach need to produce pepsin so your stomach can do this. However, in reality, your cells cannot produce pepsin because they are made of proteins, and the job of pepsin is to break down proteins. So in actuality, if they produced pepsin, they would destroy themselves. So what they do is they make a slightly different and inactive chemical that when it mixes with the stomach acid, it becomes pepsin. You're eating or drinking, especially if you do it really fast, you're swallowing air a lot of times. So air is swallowed a lot of times when you're eating or drinking, and that gastroesophageal sphincter occasionally will relax to let air out of the stomach that's there, and that is why and how you burp. Occasionally your body will detect something that is wrong during digestion, and when it feels like something is bad enough in the digestive process, it kind of goes into red alert. Alarms start going off in there, and everything very quickly flips over and begins to work in reverse. And basically it's violent contractions. Remember, you have on your esophagus, the muscles going up and down, the muscles going round and round, and they just begin to violently contract. And as that's happening, the food is being pushed back up through the esophagus, and then you vomit, which is a lovely experience. So when you take something like Pepto-Bismol or some of those medications, what it does is it stops the muscles from contracting. The problem would be then if obviously you needed to get the bad stuff out. But anyway, that is burping and vomiting. Lovely. After the food is thoroughly mixed up, it becomes this thick liquid we call chyme. Now it's spelled C-H-Y-M-E, and I thought it was chyme, but when I looked it up just to verify it, it says we say chyme. So we're going to say chyme even though I think it's chyme. It takes 3 to 4 hours for food to become chyme. It is then slowly released into the small intestine. There's another sphincter at the bottom there called the pyloric sphincter. It works very carefully to only let a small amount into the small intestine at a time. This is where most of the chemical digestion occurs. Proteins, carbohydrates, and fats are broken down by enzymes in the small intestine into small chemicals that the cells can then use. Those chemicals are absorbed through the wall of the small intestine, and it goes directly into the bloodstream. This process takes about 3 hours, which really isn't bad considering your small intestine is about 20 feet long if it was stretched out straight. The small intestine is therefore not called the small intestine because of the length, but it's called the small intestine because it's very small in diameter. It's only about 1 inch wide. So very long, but very small in diameter. The large intestine is much wider. There are 3 pieces of it, and I'm probably not going to say these correct because when I said them like this, it didn't type it in on my voice thing, but we're going to give it a shot. So duodenum is the first part of the small intestine. It's about 1 foot long. This is where most of that chemical breakdown is happening. Even though it's only 1 foot of it, it's where most of the chemical digestion is happening. The second part is the jejunum. It's 8 feet long, and then the third part is the ileum. It's 11 feet long. That last 20 feet, 11 or 19 feet of this is where the absorption is happening. So that absorption happens through these little things called villi. Now these are, that should say are, not our, are tiny like projections. There's a picture of it here, or there on your thing, this from your textbook. And they're like little fingers along the inside wall of your intestine. So you have a layer of smooth muscles which holds everything in place, and then you have your intestines there, and inside of that you have these villi, and they're like little fingers. that almost makes it look like velvet, and there are cells inside of this area that transports the nutrients from the small intestines to the blood vessels that are scattered throughout those little fingers. In order to absorb the nutrients and digestion, my picture there, I just realized cut off part of your words, but that's okay. The cells need to come in contact, like they have to touch the nutrients. From what I read in your textbook, if it was a smooth muscle in there, that it would take, let me see if I can find this, it would take 2 miles of intestines to be able to absorb enough nutrients. So we have these little intestinal villi that point down, and that way they're coming in contact with the digestion as it's happening so that it can absorb and pull out the nutrients that you need that will then put it into your body like you need it. Once nutrients are absorbed into the bloodstream, they pass through the liver. There, nutrients are either processed, nutrients are processed there. Then they are either stored and held until they're needed, or they're immediately distributed throughout the body. Now, the main thing the liver stores is glucose. Glucose, if you have an overabundance of glucose, then your liver makes what's called glycogen, which is basically just little strings of glucose molecules. Then when your body begins to run low on glucose, it breaks down that glycogen and then sends that into your body as needed. Your liver also produces bile. So after the bile is made in your liver, it is delivered to the gallbladder, and you can see in the picture right there is the gallbladder. It's stored there, it's concentrated there, and then as that chyme goes into the small intestine, the gallbladder releases the bile, which within the intestine is helping to break down fats. The liver also takes chemicals that, if left alone, would gradually build up and then would ultimately poison you from the inside out. So what your liver does is it makes those poisons less harmful. For example, as your body is breaking down proteins, ammonia is created. Now, ammonia is bad for you, and if it were to build up in your body, it would eventually kill you. So your liver takes the ammonia, it uses carbon dioxide that it's pulled from something else, and it converts this substance into another substance called urea, and then it sends it to the renal system, which is where it is removed from the body, and we will discuss that system in a minute. Another organ is your pancreas. Your pancreas produces hormones as well as digestive juices, which, by the way, that phrase totally grosses me out, but that's okay. One hormone it makes is called insulin. Now, insulin is what controls how much sugar is in your blood. If you don't produce enough insulin, then you become a diabetic, or then you are a diabetic. Not quite sure how that would work. Your pancreas also produces pancreatic juice, which is then secreted into the small intestine when the chyme arrives, and it has 2 functions. It neutralizes the acid, and it contains another important enzyme that helps digest fat and break down those proteins and starches in the intestine so it can be absorbed into your body. At the meeting point between the small intestine and the large intestine, you find another sphincter. This is the ileocecal sphincter, which opens and closes to let liquid chyme from the small intestine enter the large intestine. Now, the large intestine has 3 parts: the cecum, the colon, and the rectum. The main job is to produce feces, which is technically waste material, which is your poop, right? Water is absorbed through the wall of the large intestine into the bloodstream. It's still working on pulling nutrients out that our body needs. Your large intestine has millions upon millions of friendly bacteria that's working to continue to digest the food you're eating. And those end friendly bacteria are digesting some otherwise indigestible things, and in doing that, they produce vitamins that are then being absorbed into your body. One of the most important ones that you absorb at this point is vitamin K. So it is a very important step in your nutritional cycle. All right, there's this tube on the cecum called the appendix. This appendix provides a safe place for friendly bacteria to hide when your body gets an illness that could kill that bacteria. It's a safe haven for them to stay alive when bad things are coming. The bacteria in your intestines can digest complex carbohydrates, but in doing so, those bacteria begin to release several different gases. As you have an overabundance of these gases, side effects happen, and we call that excess gas side effect flatulence. And then as this large intestine is working through the large intestines, you have wave-like muscle movements that are continuing to move the chyme through the large intestines. As those muscles are contracting and releasing, more and more water is being removed. And this can take anywhere from half a day to 3 days, honestly, depending on your diet. If you have a diet high in fiber, it speeds up the process. All right, the rectum is the last section of the colon. It is here feces are stored before being eliminated from your body. Now let's talk about urine, and then we are done with this unit. Urine is produced in the renal system by these special organs called your kidneys, and there's a diagram of this. Much of the waste in your body, much of the waste that your body produces enters the bloodstream. From there, it is sent to the kidneys for processing. The kidneys are like I always say it's like a filtration system. When your blood enters your kidneys, it encounters millions of tiny purifying systems that remove waste and water. That wastewater is what becomes your urine. Urine then trickles down through tubes called the urethras, and this then leads to the bladder, and then you know the rest from there. That is the end of lesson 4 in your textbook. I need you to make sure you have your notes filled in, bring those to class with you, and we are going to discuss an upcoming project.